Hi everyone, welcome to this tutorial. Today we're gonna learn how to turn on and off an LED using a push button. Uh, Here we go. What we need is a push button, a breadboard, an Arduino, an LED, resistors, and some jumper wires. Okay, let's go. First of all, uh, we need to put our we need to put our push button on the circuit. So, so let's go. Thank you. Great. Yeah, you have. Can you see it? Perfect. The next step is to add our LED in the circuit. So we add our LED. We're going to connect our push button to the Arduino and the LED again, also to the Arduino. So let's go. Uh, we supply uh, 5 volts to the to the push button. Here you have 5 volts, 5 volts. After that, what you have is uh this the next leg of the push button goes to digital pin number digital pin number two, digital pin number two. Okay, digital pin number two. The next thing is the third pin of the push button, which is connected to the ground. It is connected to the ground. Here it is. You have the ground. This is the ground. This is the ground. The ground of the Arduino. Okay, and uh, let's go for the LED. Here, this is let's say, okay, right. This is the short leg of the LED. Gas to the ground, and the long leg of the LED. Gas to digital pin number 13. Perfect. Right. The circuit is now away. Now we can go for the code. Okay. Perfect. We can go now for the cards. Let me reduce this. Right. Perfect. So as I told you, there are two methods. Okay. So the first one, The first things that we're gonna do is to initialize our pin. So here we have const int the bottom pin. It is pin number 2, and const int LED pin. This is digital pin number 13. Okay, right. Pin mode here is gonna to be the bottom pin. This is input. Why input? Because we need to press. We need to press. We need to press the button, and this button will send signal to our circuit. So this is an input pattern, an input device. Okay. The pin mode of LED pin. It is an output, and here the void loop int a button states is initialized to digital right digital read, sorry. We read the state of the push button, which is the push button pin. uh, if the button is pressed, uh, so if the button is held, if the button is pressed, then the digital white of the LED pin is held. Okay, else digital white LED pin is low. Right, perfect. Let's verify our code. Oh, okay, an error. Digital what was not declared in this scope. Ah, sorry. Okay, here it is digital. Okay. Uh, what's wrong here? Uh, this is line 19. Okay, yeah, you have. Okay, verify again the code. Right, perfect. We can upload it. Well, very good. Now let's go. When I press the button, the LED turned on, and when I release the button, the LED turn off. But the second thing that we want to do is when we press the button, the LED should stay on, and when I press it again, it should stay on, or sorry, off. So we press one, the LED should stay on, and when we press again, the LED should stay on. Okay, so let's modify our code so that we can do that this small project. Okay, so we have already const in button pin, const in LED pin. Okay, Okay. This is bind uh, the last bottom state. The last bottom state should be low. Bind uh, the LED state should also be low. Uh, Unsigned along the bounce. The debounce situation equal to this is in millisecond. Unsigned, okay. Unsigned long last time bottom state change. Let's say that equal to 0 is initialized, sorry, to 0. And then the pin mode, the LED, it is an output, and the bottom is the input. Okay, so if uh, let's go for the loop function. Here you have if the mill is minus if the mill is minus the last time the bottom state change is superior to the bounce duration, then what should happen? Okay, the bottom state should be the return with the state of the bottom. It is the bottom pin. Here is bottom pin pass. If the button state is not equal to the last bottom state, and then what you have is the last time bottom stage of change is millis. Last bottom state is receive the bottom state, and if the bottom state is low, then the LED say become uh, LED state is high is high. Then generator right LED pin LED state. Right. Oh, sorry. Oh, let's verify our code. Ah, okay. If last time bottom state change. Okay. Device duration. Oh, where it is. This is line. The error is here. Line 21. Okay. This is change. Right. Let's verify again our code. Ah, perfect. Very good. We can upload it now. Perfect. Right now, when we pressed our button, the LED turned on and stayed on without touching again the button. And when we press again the button, the LED turned off. Again, on, off, on, and off. Okay, right. What we can also do is to define this as define, and this also is defined. Let's upload again our code. Okay, there is a mistake here. Okay, let's verify again the code. Perfect. Everything is working. Upload it. Test again the circuit. Very good. Very good. Okay. Let me explain you line by line the codes so that we can all understand. Okay. Very good. So the first line is very important. This is a this creates a constant before compilation, and the LED pin is connected to generator pin number 2. Sorry, the bottom pin is connected to generator pin number 2, and the LED pin is connected to generator pin number 13. And after that, we store the previous we start the previous state of the buffer. As you can see, nothing happened yet, but so the button is low. So we assign the previous state of the button to the last button state, and we do the same thing with the LED state. After that, we need um, to assign a times for our button state for our button to to our circuit to catch the button state, so that for example, when a mechanical button is pressed, it doesn't switch cleanly for a few milliseconds. This is called button bounce. The program waits 15 milliseconds before accepting another state change. So we saw the last time the bottom state change, and we start generally at 0. Etc. etc. So here you can read the code step by step, slow by slow, and understand everything. I will put also the code on my GitHub so that you can have access to it. It is very simple, and you can do it yourself at home. Very simple. So this is all. and see you next time for the next video. Bye bye.